when we go to draw our sketch for 120 degrees, okay, hopefully you have it ending in the second quadrant. Okay, remember that it is starting from our positive x-axis and going. Okay, our reference angle occurs when we take our terminal side and go down to the x-axis. So our terminal or a reference angle is going to be this angle that is formed here. So if over here is 150, or sorry, not 150, 120 degrees, okay, what would our reference angle if we want to finish that full half circle? 60 degrees. So our reference angle is 60 degrees. Okay, now why is that important? Well, yesterday, if you remember, I talked about how we are going to draw triangles all the way to the x-axis. So the reason why we need that reference angle is because this now becomes a 60-degree angle, and now we have a 30, 60, 90 triangle that we are going to use in order to evaluate sine of 120, cosine of 120, so on and so forth. So that's the purpose of that reference angle. Okay, so understand that it's from the terminal side to the x-axis. Okay, all right, so what about negative 120? If we draw our 120 going this direction, okay, because it's negative, what's our reference angle? It's still going to be 60 degrees because that takes us the rest of the way to the x-axis. Okay, so we would just simply say the reference angle equals 60 degrees. Okay, all right, and the reason why I have that third example there is if they ask for the reference, if they give you the reference angle or they're asking for it in degrees, give your answer in degrees. So in C, since they start in radians, give your answer in radians, okay? So we have to draw 4 pi over 3, okay? So we should understand that 4/3 pi is more than 1 pi. 1 pi, remember, is 180. So 4 pi over 3 is going to get us all the way down to here, right? Okay, so this is our 4 pi over 3, which means we're still going back to the x-axis, so our reference angle is going to be this one. What would that be in radians? How much beyond 1 pi did we go? If we went 4 pi over 3, 1/3 pi, because if you take away 1/3 pi, now you're back to 3 pi over 3, which is 1 pi. Okay, so it would be pi over 3. Okay, so your reference angle equals pi over 3. All right, so let's say you struggled with the radians. What could we possibly do? Convert to degrees. Okay, so you could have changed that 4 pi over 3 to degrees, figure out the reference angle in degrees, but then you got to take that reference angle in degrees and convert it to radians. Okay, so if you need to do that, do that. Okay, any questions on what a reference angle is? We're going to use it throughout the process today, so we'll get more practice with it. Okay, next. Review from just basic geometry when we learned about our 30, 60, 90 triangles and 45, 45, 90 triangles. So draw a 30, 60, 90. Okay, so I'll put my 30 degrees down here. I've got my 90 degrees here. I've got my 60 degrees here. Does anybody remember how you would label your sides for a 30, 60, 90? Anybody learn this? Yeah, do you remember?
I don't remember it though. Isn't it like 2x or like x or like square root of 3 or something like that?
Excellent. Yeah, you are correct. So opposite the 30 was 1x, so we're just going to say 1, okay? Opposite the 60 is root 3x, or we're just going to say root 3. Okay, and then opposite the 90 is 2x, or we're just going to say 2. Okay, so you are correct. All right, now how do you know which one is opposite which? Okay, always remember that the smaller angle has the smallest side opposite. The second smallest angle has the second smallest side opposite it. And then the largest angle has the largest side opposite it. Okay, if you're not sure about the value of root 3, type in root 3 on your calculator right now. What's root 3? 1.73. So do you see that 1.73 is between 1 and 2? 60 is between 30 and 90. So always understand, based upon our hinge theorem concept, that the bigger the angle, the bigger the side opposite, right? Ring a bell? Okay. Now, here's all I'm going to do is I am going to change this a little bit from what you learned to what we have been talking about, and that is the unit circle. And remember, we said in the unit circle that our hypotenuse is always going to equal what number? 1. So how can I change a 2 into a 1? Oh, well, if I divide this side by 2 to get 1, I have to divide this side by 2, and I have to divide this side by 2. And so we are going to use the idea that opposite the 30 is 1/2, opposite the 60 is root 3 over 2, and opposite the 90 is 1. We're going to use those values instead, and now it's consistent with our unit circle. Okay? All right, so let's just quickly practice. What is sine of 30 degrees? 1/2. How did he get that? Explain.
30 opposite is half, and sine is the y value.
Okay, so it's the y value, so he said it's just 1/2. Or if you remember that sine is opposite over hypotenuse, 1/2 divided by 1 is just 1/2. Okay, so somebody else. What would cosine of 30 degrees be? Use what he just said. Very good. Root 3 over 2. It would be your x value, your horizontal value. Okay? Eventually, remember we're going to talk about SOHCAHTOA. Cosine would be your adjacent, your root 3 over 2 divided by the hypotenuse 1. So root 3 over 2 divided by 1 is root 3 over 2. Okay? All right, tricky one. Tangent of 30. Root 3 over 3. Very good. Okay? Understand that it technically is 1 over root 3, but then she rationalized it. Right? Good job. You did that quickly. Good job. Okay? All right. So now let's switch the angle from the 30 degrees to the 60 degrees. Okay? What's sine of 60 degrees? What's opposite the 60 degrees? Root 3 over 2. What is cosine of 60 degrees? What's adjacent to the 60 degrees? 1/2. And then tangent of 60 degrees.
Root 3.
Just plain old root 3 because it would be root 3 over 1, so just root 3. Okay? And you should have learned about how the two tangents are reciprocals, how the sine of 30 is equal to the cosine of 60, about how the cosine of 30 is equal to the sine of 60. You should have learned all that and, recognize that there's a pattern to it. Okay? All right, so again, this is all review, and then I'm going to come down and I'm going to show you the hand trick in order to help you remember some of this as well. All right? But before we do that, let's do the 45, 45, 90. Looks like I'm going to run out of room. Okay? All right, so 45, 45, 90. Remember that the 45, 45, 90 comes from half of a square, so tick, tick. Okay, remember that those two sides are always going to be equal to each other because it's an isosceles triangle. All right, so you got your 45 degrees. Does anybody remember the side lengths for this? Yes?
Isn't it like the square root of 2?
Okay, where should we put that one?
On like across from the 45s?
Okay, so you want to put a square root of 2 here and square root of 2 here?
Yeah.
Okay, then what do you want to put in the hypotenuse?
No, it's like 1 and then the square root. No, I don't know.
Okay, does anybody else remember? We can use the square root of 2's, but then you have to give me the specific hypotenuse. So it's fine. Anybody? Okay, so you probably learned, like how you were saying 1x, 2x, root 3x, okay? So you probably learned it this way, that it was x root 2. So 1 root 2. Does that ring a bell? Did you learn it that way? Maybe? Okay, maybe some of you did, some of you didn't, okay? But remember that what we're going to do is we want our hypotenuse to be 1, so how can I get my hypotenuse to be 1? Divide by root 2, which makes this a 1. But if I divide that by root 2, I have to divide this by root 2, and I have to divide this by root 2. Well, the bad thing about that is now I got root 2 in the denominators, so can somebody rationalize that for me real quick? Root 2 over 2, okay? So we've got a lot of information here, so let's erase what we don't need or cross out what we don't need, and that is we are going to understand the sides are root 2 over 2, root 2 over 2, and 1. Those are going to be our sides, okay? All right. With these, it's a little bit simpler because what is sine of 45 degrees and what is cosine of 45 degrees? Root 2 over 2 for both, because remember that your opposite and your adjacent are equal to each other, okay? And then what is tangent of 45 degrees? 1, because it's opposite over adjacent, and they're equal to each other, so anything divided by itself is 1, okay? All right, to help you with this, okay, I'm going to show you this idea of the hand trick. You can use it if you want. You don't have to use it if you don't want to, okay? The very first thing is you have to look at the back of your left hand, okay? And I'm going to draw it up here on the notes so that you have it as a reference, okay? And then we'll kind of practice with it, okay? All right, first thing is we will take whatever answer we get from doing our hand trick, and we are going to divide by 2, okay? That's the number one thing. And the reason is, if you look at sine of 30, it's 1 divided by 2. Cosine of 30 is root 3 divided by 2. Your sine of 45 is root 2 divided by 2. Notice that you're dividing by 2 all the time, okay? Number 2 is whatever answer we get from our fingers, it is going to be the square root of it, okay? So notice that we have a square root of 2, we have a square root of 3. Yes, we have a 1, but what's the square root of 1? 1, okay? So we can easily figure that out, okay? Next, okay, this direction, when we count our fingers, is the sine direction, okay? So if we start at our thumb and go in a counterclockwise direction, that's sine. And if we go this direction, start at our pinky and go, that is cosine, okay? Last piece of information is our angle measures, okay? So your thumb represents 0 degrees, your index finger is 30, then we go 45, then we go 60, and then we go 90, okay? And if you're coming from the cosine direction, it's the exact opposite, okay? 0, 30, 60, so on and so forth, okay? So just, but I'll show it to you here in a second, okay? Let's pull up our answers so that we can check it.
And Taylor, who's Kelly? Go Taylor.
Yeah.
Nuts, like-
All right, so the second part of this, it's going to take our reference angle concept, it's going to take our hand trick concept, our 30, 60, 90, 45, 45, 90, and we're going to put it all together, okay? So when we're doing these, today I'm going to show you, how to do it in general, but at some point we got to be able to do it without the picture, okay? All right, so we're going to start with cosine of 150 degrees, and I am going to draw my 150 degree angle, okay, so that I can figure out my reference angle. So the reason why I'm drawing is to figure out the reference angle. That's the purpose, okay? All right, so 150 degrees is here, okay? What is my reference angle? 30 degrees, okay? All right, so here's why we're doing this, okay, I am going to drop a line, make a right angle, and I have my 30 degrees as my reference angle, making this angle at the top 60 degrees, right? All right, so now I gotta label my sides. What is the hypotenuse all the time? 1. What's opposite the 30? 1/2. And what's opposite the 60? All right, so there's a tiny little thing that we have to remember right now. Does anybody want to adjust anything that we have up there? Yes.
Is it negative root 3 over 2?
Why is it negative root 3 over 2?
Because we're in the negative.
Love it. Good job. Okay,
Because why?
excellent. Well, aren't we on the negative side of the x-axis? So since we're on the negative side of the x-axis, our x value, the root 3 over 2 has to be negative, but the 1/2 is going up, so it's positive. Okay? All right, so now, cosine of 150 degrees is the same thing as the cosine of 30 degrees, our reference angle. But we're not going to say that. We're going to say cosine of 150 degrees is equal to what? What is the cosine from our triangle that we drew? Negative root 3 over 2. Okay, because remember, it would be your x value. So it would be the value that is on the x-axis. Okay, so remember, you still have to have your understanding that sine is y, cosine is x, and tangent is y over x, okay? So we still are using that concept as well, okay? While we have this picture, why don't we skip over to C, and someone tell me what sine of 150 degrees is? 1/2, very good. So sine of 150 equals 1/2, because it's the y value, it's the side that is opposite the 30 degrees, our reference angle. Okay? All right. Questions before we do the negative 150? Okay? All right, so all I'm going to do for the negative 150, I'm just going to draw a new picture. Okay? And I am going to put my negative 150 down here, because remember, negative 150 goes this direction. Okay? What is my reference angle? 30 degrees. Okay? All right, so I draw my right triangle, and now I go and label. Hypotenuse is 1. What's going to be opposite the 30 degrees? Oh, in terms of the side, not the angle. 1/2. Okay, so Mia says that there's a 1/2 here, and then what's on the x-axis? Root 3 over 2. All right, and then a couple people are saying negatives.
Negative 1/2.
So the 1/2 should be negative, and the root 3 over 2 should be negative. Okay, if you're not sure why, okay, again, we're still on the negative x-axis, and notice that we went down, and so that's why the 1/2 is negative. All right, so cosine of negative 150 is the same thing as the cosine of 30 still, okay? And so we would say cosine of negative 150 is equal to what? Is still the negative root 3 over 2, because we're still in using that negative part of the x-axis, okay? All right, and so then, since we already have the picture drawn, what's the sign of negative 150? I heard 1/2. It should be negative 1/2, because remember, we went down. Okay? All right, so recap. We're drawing the picture to draw our reference angle. The reference angle tells us what type of triangle we have, whether we have a 30, 60, 90, or a 45, 45, 90. They will all work out to be 30, 60, 90, or 45, 45, 90. They won't be a 40, 50, 90, okay? They'll all work out to be 30, 60, 90, 45, 45, 90, okay? And then from there, you got to be able to label your sides. The big thing that Abby picked on right away is make sure that you're labeling with your positives and negatives, okay? Otherwise, remember your concept of all students take calculus so that you remember which is which, okay? All right, so example 3,
Nah, we can see.
or, okay, then how about example 4? Example 4? Okay. So example 4, you got a couple of concepts here. Number 1, what if you don't like the 3 pi over 4? What can you do? Convert it. All right, what's 3 pi over 4? I heard 270, that's incorrect. And understand that it's less than 1 pi, because it's 3/4 pi, okay? It's what?
135.
135. 1 pi is 180, so it's got to be less than 180. Okay, so he says 135 degrees, okay? So if you need that in order to draw your picture, okay, then do that, okay? So I've got 135 degrees is all the way out here. Okay, what's my reference angle going to be? 45 degrees. Okay, so I draw my right triangle, and now I got to go and label. The hypotenuse is equal to 1. Opposite the 45, root 2 over 2, and opposite the other root 45 is also going to be root 2 over 2. Do we want to add anything to any of these? Which one's going to be negative?
Well, the 45, the bottom, the x-axis.
This one, the bottom one, okay, because it's still a negative x-axis, right? Okay, so we're talking about the cosine of 3 pi over 4. So leave it as 3 pi over 4, don't say cosine of 135, because it's the way it's given, is equal to what? Negative root 2 over 2. Remember, it's the negative one because it's the x value for cosine. All right, so while we're at it, okay, what is the sine of 3 pi over 4? Okay? And then when you do the other two, you may want to just draw a new picture, okay? All that simply means is that you're going to a negative 135 degrees, so this is negative 3 pi over 4, okay? Which leaves you pi over 4, which is same thing as 45 degrees, okay? Understand that we are going to label this with a 1, a negative root 2 over 2, and then another negative root 2 over 2. Because we went left and we went down. Yes?
Instead of doing, like sine 3 pi over 4 equals, could you just write root 2 over 2? Or do you have to go that extra step? And write down what you're doing?
Cosine 3 pi over 4 equals negative root 2 over 2, so negative root 2 over 2?
Yeah.
Yes. Okay. Because the homework is already going to have the questions, so you just write the answer, yes. Okay? All right, so what is cosine of negative 3 pi over 4? Negative root 2 over 2, and sine of negative 3 pi over 4? Negative root 2 over 2. Is that what you're saying to do? Done.
Can we go over then, example 3?
You want to go over example 3? We can go over example 3.
I was just gonna say for example 3, do you just solve it how we were doing and just take yours?
You do the exact same thing, okay? All right. So what she's saying is you got your 225 degrees, right? Where is that? What quadrant? Quadrant 3, okay? So remember 225 degrees is going here, okay? That's your 225. What's your reference angle though? 45. That gets you back to the x-axis. Okay, and so we should be able to label this as negative root 2 over 2 and negative root 2 over 2, okay? So when we go to do the secant of 225, she's saying that is the same thing as 1 divided by cosine of 225, or 1 divided by negative root 2 over 2. And so what does that end up being? If you flip it. Oh, so it's a good thing we did this one then.
Negative root 2 over 2.
So remember, we're going to flip this, and it'll become a negative 2 over root 2, right? Rationalize, right? And then you're gonna end up with negative 2 root 2 over 2. They're saying the 2's cancel, and so it's just negative root 2, okay? So up here, our answer is just negative root 2 for the very first one, okay? So you are correct, okay? Just use the idea of the same thing, just use the concept of the reciprocal, okay? Tangent, remember, if you wanted to skip to C because it's the positive one and we already have the positive one done, remember that tangent is y over x. Your y is negative root 2 over 2. Your x is negative root 2 over 2. So if I take negative root 2 over 2 and divide by negative root 2 over 2, what does that equal? 1. Okay? And remember how we said that all students take calculus. Tangent should be positive in the third quadrant because of a negative divided by a negative, okay? All right, so like I said at the beginning of this, is right now I'm showing you how to draw the picture and come up with it. At some point, we want to get to the point where we don't necessarily need to draw the picture because it'll slow you down, okay? So things that I'll talk about tomorrow would be like a quick way to figure out the reference angle for 225. It's just do 225 minus 180 is 45, done. And now you can just go from there. Okay? Questions for today?
So
Yeah.
when you do that, can you just use the all students take calculus?
Then you can use the all students take calculus. You can use your hand trick, you know, okay?